And of course the potential drop across a cell is its EMF. Now let's describe this now. In the loop A, B, E, F, A, do you see how I am tracing that loop? The potential drop across the 2 ohm resistor, the potential drop across the 2 ohm resistor is 2I1. It is positive. Why is it positive? Because the loop is traced A, B, E, F, A. Look at that. The direction of tracing the loop and the direction of the current I1 are the same. Therefore, the potential drop across the 2 ohm is 2 times I1. That is positive. How about the potential drop across the 5 ohm? Can you tell me, is that positive or negative? Again, the loop A, B, E, F, A is traced out in the direction of the current I2. Therefore, the potential drop across the resistor 5 ohm is 5I2. That is positive. How about the potential drop across the cell when you trace out this loop A, B, E, F, A? That loop passes from the negative to the positive through the cell. That means the potential drop across this cell is negative 6 volts. When the loop is traced out from the negative to the positive through the cell, the potential drop across the cell is negative. Now, we have 3 elements in that closed loop. Can you apply the second law and form an equation? What does the second law say? The algebraic sum of the potential drop in a closed loop is 0. So add all this, 2I1 plus 5I2 minus 6 equal to 0 is that equation. Alright, let's take the loop B, C, D, E, B. B, C, D, E, B. Is that loop clockwise or counterclockwise? It is counterclockwise. What is the potential drop across the 4 ohm resistor? You can see the direction of tracing of the loop and the direction of current in that current I3. I3 is the current in the 4 ohm. The direction of I3 and the direction of the loop are the same. Therefore, potential drop across the 4 ohm is 4I3, which is positive. How about the potential drop across the 5 ohm? Look at the way the loop is traced out. BC, D, E, B. The loop goes opposite to the direction of the current I2. Therefore, the potential drop across the 5 ohm resistor is negative 5I2. And so, can you write an equation for this loop? Very simple. 4I3 minus 5I2 equal to 0. The algebraic sum of the potential drop in a closed loop is 0. We can find the values of I1, I2 and I3 by setting up equations using the 2 laws of Kirchhoff and solving those equations. Okay, let's do that. Applying the first law to junction B, let's use the first law to form an equation. We have, let's take junction B. Watch how the currents are arriving and leaving junction B. If you watch, I1 arrives junction B, I2 leaves junction B, I3 leaves junction B. Now, can you write an equation using the first law, the algebraic sum of the currents meeting at a point is 0. It means I1 minus I2 minus I3 equal to 0. You have one equation there. Okay, there are three unknowns. If you want to solve for three unknowns, we need three equations. Alright? Applying the second law to the closed loop A, B, E, F, A. A, B, E, F, A. Alright? We actually did that. Let's now see. That will be the potential drop across the 2 ohm is 2I1. And look at the way I'm tracing out the loop. There you are. The potential drop across the 2 ohm is 2I1. The potential drop across the 5 ohm is 5I2. And the potential drop across the cell, the loop is traced out from the negative to the positive. So that will be -6. Add all those potential drops together. The algebraic sum is 0. 2I1 plus 5I2 minus 6 equal to 0. And that is 2I1 plus 5I2 equal to 6. I have the third equation. The second equation. Can you obtain a third equation? Where will you go for the third equation? Let's go to the closed loop B, C, D, E, B. B, C, D, E, B. Well, we have already done that. You can see in B, C, D, E, B, the potential drop across the 4 ohm is positive 4I3. And the potential drop across the 5 ohm is negative 5I2. So it is negative 5I2 plus 4I3 equal to 0. Look at that. We have now three equations. Now, these equations can be solved on TI-83 or TI-89. or any graphing calculator. I will show you a method which can be used on any calculator. And in order to do that, we need to rearrange this equation. Look at the way I wrote my first equation. I1 minus I2 minus I3 equal to 0. I wrote it as 1I1 minus 1I2 minus 1I3 equal to 0. It is important to identify the coefficients of the variables. Now, I want now to write the second equation. Now, if you look at this, the second equation does not contain I3. So you must write the second equation using a 0 as the coefficient of I3. Look at the way I wrote it. 2I1 plus 5I2 plus 0I3 equal to 0. We want all three variables in all the equations. So write it like this. 2I1 plus 5I2 plus 0I3 equal to 6. In that case, how will you write the third equation? Well, your first term must be in I1, the second must be in I2, and the third in I3. So, since there is no I1 in that third equation, you will start by saying 0I1 minus 5I2 plus 4I3 equal to 0. This is the third equation. 0I1 minus 5I2 plus 4I3 equal to 0. Okay. Once you write the equations like this, how do we solve it? Alright, I'm going to show you how to do it on a TI-83. And you can actually use the same method on any other calculator. Okay? Alright, give me a second. I have now the three equations on the whiteboard. See if you can read them. 1I1 minus 1I2 minus 1I3 equal to 0. 2I1 plus 5I2 minus 0I3 equal to 6. 0I1 minus 5I2 plus 4I3 equal to 0. Now the first thing to do is to make a matrix using the coefficients on the left side. Now this will be a 3 by 3 matrix. In other words, it will be 1, negative 1, negative 1, that is the first row. 2, 5, 0, the second row. And 0, negative 5, 4, that is the third row. So make a